So this week we're going to talk about data classes, and data classes are a new feature that was introduced in Python 3.7. They were described in PEP 557, and what they do is they describe a way of automatically creating a lot of boilerplate for common class instances that are mainly designed to just hold a bunch of data. Now, what we mean by this, so if you if you want to follow along on the documentation, I will post that in the chat. Go. So what is meant when we were talking about a data class is a class that is don't need to inherit from anything. A class that basically looks like this, and this is going to build on the type annotation and MyPy stuff that we talked about last time. But we're not going to worry about any of that yet until we get into actual data classes. So oftentimes you'll see classes that are defined that look something like this, and they've got a whole bunch of values that need to be passed to the constructor. D equals 1, and then C, and then E equals, let's say none, and we'll get to E here in a second. And then you end up doing something like this: self dot A equals A, self dot B equals B, and and it just goes on and on. Oh, let's see, 1, 2, 3, 4, and then E is special. And we'll get that to stop complaining. So then, B, C, and and this is lovely and it's tedious. And then E is actually supposed to be a list. So we go if E is none, E is a list. And then we go self E equals E. Something like that. And the reason that we do this is if we did something like this, then E becomes, if E is the default value, this one instance of a list gets shared between all of your classes, because this is only being created once at the time the class is, the class definition is being built. So the workaround for that is typically to do something like this and then check for a none value. And if it is a none value, then you say, okay, we're going to create a new list and then we're going to assign it. Okay. So this is not uncommon. And then you end up doing something like, let's see, Reaper self, and then you do, let's see, return. Hey, Brenda, would you mind muting?
I'm sorry, I thought I was mute.
It's okay. Thank you. And then you'll do something like this, where you'll return a string, and it will be class A, and then it will be, let's see, you'll see something like this, F A, and then it'll be like the value self dot A, and you'll end up with something like this for your Reaper. And then let's see, we want to do a quality testing. That's not the default. So then you're like going through and comparing all your elements. What about other comparison functions? And so there's this boilerplate that comes out of these classes that the data class decorator in Python 3.7 provides to basically do all this stuff for you. So let's look at how we would do that using data classes. So we're going to import the data classes library. So I'm running, let's see, make sure I got make sure I'm running the right version of Python here. 3.7.2, so this will work, good. So we're going to go from data classes, import data class, And then we're also going to import field, which we will use later. Okay, so what data classes allows us to do is essentially do the exact same thing that we've got here, with with variable annotations. And so we do that like this: data class, and we don't I'm sorry, at data class, there we go, class A, and then we do not define a constructor, and we do not define a Reaper function. Instead, we annotate the class. We create annotations for our different variables. So we go A is a string, B is a string, let's see, C is a string, D is an integer, and we're going to say that this defaults to the number 4. I'm just pulling stuff. And then E is a little bit special. E is a list. So we're going to do from typing, like we were doing a couple weeks ago with MyPy, import list so that we can describe the type of E, and we'll say it's a list of integers. And let's see, why is D complaining? Fields with default value must come after any fields without a default. Okay, I'm working on it. Equals a field, and then we're going to say we're going to give it a default factory of list. So now this has everything it needs to automatically create an equivalent constructor to what we did, a equivalent Reaper method, and an equivalent equality equal operator. We can also ask it to set up order operators and hashing functions for us as well. And so you're like, well, okay. So let's play with this a little bit. So if we instantiate an instance of A, let's call it, well, A equals A, and then we can come through and we can say, okay, well, PyCharm is awesome because it already understands what we've done with data class. And it says, well, okay, we need an A, so foo bar. Maybe I shouldn't have given it so many fields, but that's okay. And then we already have default values for D and E. So then we can do print, and we can do the Reaper and the representation of A. So let's go ahead and run this. Okay, so that gives us our representation of A, and it's exactly what a Reaper function should look like. And it explicitly calls out the names of all of the variables and their values. So D equals 4, and then E equals an empty list. So this does the right thing with lists, and it creates our Reaper method automatically. Okay, so let's look at some of the options for creating our data class here. So this is the default behavior. This is what we get out of the box. We get a constructor that initializes all the variables in our instance. We get a Reaper method, and we get an equals method. So let's do p equals, not this guy. Let's do that right there. Something like that. And then we can print the Reaper of B, which will be slightly different. And then we'll go ahead and print out if A equals B. And so this is our compare. Let's see. Why? What is? Okay, it's just. And this should print false. So now we've got the basic equality operator. So if we do something like this, it's going to complain because less than is not supported between two instances of A, which is correct. PyCharm is nice enough to mention that for us. And if we try and run it, of course, we get the appropriate error. So what else can data class do for us? So, well, it can also create rich comparisons. So if we say, let's see, init order. So if we say order equals true, this will give us all of our comparison operators. And now the instance of A is less than the instance of B. The way it does comparison is it treats it like comparing two tuples. It goes element by element in the order that they are defined. So it first compares A, then B, then C, then D, then E. And of course, the attribute C is different in these two data classes, in which case the string C in instance B is greater than, bonk is greater than Baz, and so A is less than B. Okay. Now we can also, so then these methods or then these instances can be modified directly. So we can go e dot append, something like that. And let's see, go ahead and grab my print methods and stick them on the end here. And so now our now we've appended the string 1, 2, 3 to E, and of course it does the right thing because he's been initialized properly. We can also declare these classes frozen. Now it's not technically possible to truly make an instance of a class immutable. Frozen just basically does the simplest thing and implements getters and setters, or implements get attribute and set attribute. And if you try and set any attribute on the class, it will fail. Now, this will not fail in this case because even though I'm modifying E, I'm modifying in its place. I'm not modifying the value of E. So if I tried to do something like this, A.E equals a new list, something like that, it will complain because it says E is read-only, and this is just PyCharm understands how data classes work, and that since I've declared this frozen, as soon as I try and do an assignment, PyCharm is it's just figuring it out and calling it out for us. And if we try and execute this, then you see that we have a frozen instance error. We cannot assign to the field E. And this is true if we try and reassign any value within our class. Now, once we've declared this frozen, then our classes then become hashable. Now, you can also declare an unsafe hash, which is if your class is still mutable but hashable, you're not really supposed to do that. That kind of goes against the intent of hashing. But normally, if you want something to be hashable, you just declare it frozen. So now we can print the hash of, let's say, B. And we'll go ahead and remove this line that fails right here. Okay. And so this will give us, let's see, unhashable type list. Oh yeah, I guess that's true. So let's take out our list here. And let's take out our append statement and run that again. All right, so now that gives us a hash of object B based on the values that were supplied by based on the value of the member variables. Now, and we also know that it's not using the fallback method of just using the ID of the instance of the class, because it's, in this case, the hash is a negative number, and that just happened to work out. So just out of curiosity, let's get the hash of A and see how they're different. Oh, that's right. We've got random they're randomly seeding the hashes as a security feature. So you can shut that off so you get the same hashes every time, but every time you run the interpreter, it seeds all the hash values that are created automatically. Yeah, and if you want to go and get into a discussion as to why that is, we can talk about that later. Okay. So let's see what next. You can specify your own init function, but if you do, then of course data class cannot produce its own init function. So what if you want to do some extra work on these variables or declare additional variables? So we can also declare variables that are not initialized during let's see, that are not initialized in the init function. And the reason for that is if their value is based on the other values that are passed in, you're going to want to initialize them yourself. So we've got two problems that we need to solve here. It's like, how do we do our own initialization without overriding the init function that comes with data class? And how do we prevent it from initializing the value of one of the variables in its automatically generated initializer? So the first thing that we can do is we can do we declare a method as a field. We give it a default value of 1, 2, 3, or we do not give it a default value, and instead we say init equals false, and this will leave this uninitialized in the constructor. Now, how do we set up our own init? So we do def post init. And this, the data class, after it runs its own init, will automatically execute post init if it exists. So this is where you would do your init functions if the basic constructor doesn't do what you need it to. So we could do something like self.e equals let's see, self.a plus self.b, for example. That's a good point. I believe we can do this as frozen, but we would need to use set attribute in order to make it work. But for now, I'm just going to get rid of that, and we'll get rid of our hashes. So now if we run this, we see that our variable E is the concatenation of A and B as we defined it earlier. So that's how you would do your own initialization after the default initializer runs. Okay, let's see. Also, when we define our field, we can tell it to be left out of the Reaper, or so if we set this to false, this will be left out of the Reaper representation of our function. And this is, a perfectly legitimate thing to do, because oftentimes if your since this really can't be passed to the constructor, it wouldn't necessarily be appropriate to include it in the Reaper representation. So it's kind of, what do you want from the Reaper? So typically the rule is the Reaper should, it's not required, but it ideally should produce something that if you were to feed it back to the Python interpreter would give you an equivalent instance of the class. So in that, if we wanted to follow that rule strictly, we would leave this variable out of the Reaper output, because it's not passed in as a member variable. But if we want like an accurate representation of the state of the class, and that's more important to us, then we would leave it in. And so, usually, if it were me, I would leave it in because this class is not frozen. Somebody could come along later and change E, and you would want to know what the new value of E is, and so you would definitely want to leave it in. So, okay, what else can we show off here? We covered that. We've covered that. Okay, so there's also let's see, the asDict method, and this is fun. So what we can do is we can get a dictionary representation of our class. So this is actually a common thing to do when you want to come up with a serializable version of your of a class instance. Say you want to serialize it as JSON or something like that. This is actually a very common problem in the backpipes library that we use extensively, that I used extensively in the on Voltron, converting instances of classes from Dict. Now, he didn't have data classes available. The author of the library didn't have data classes available when he wrote this, so he had to write asDict methods all over the place that pulled apart the important parts of his class and put it into a dictionary, so you could get a representation of it. So if we call asDict on one of our class instances, so we'll just go ahead and print that. Print asDict, and we'll do B, something like that. It just basically returns an instance of our class as key value pairs. You can also do asTuple, which does the variables. Let's see, how is it written? It's the variables in order as they were defined in the class. There's no keying available. So let's see. So if we just to demonstrate what I'm talking about here, just in case I'm not clear, tuple. So let's go ahead and do this for B again. Nope. There we go. And we run that. You're going to see that it has all of the members of our class in the tuple in the order that they're declared, but they're not given names. Okay. Let's see. There is the replace method. So let's see. Brandon, do you know off the top of your head how to set the value of E in post-init if we've got if our data class is considered frozen? Would we just use set attribute?
I wasn't able to figure it out. I have the same type of issue.
Okay, so you've tried to do it and you haven't been able to get it to work?
Yeah.
Okay, well then we'll for this I'll just go ahead and rip it out. Okay, let's go ahead and get rid of all this stuff. So we can't modify our instance of A or B, and data class also has a method called replace. I assume that the main time you'd want to use this is if you've declared your class data class as frozen, although it's just going to be useful in general. You'll recall that the datetime object has a similar method, and so you would do something like this: replace, and then our object. So let's say object B. Say that this is C. We're going to replace object. We're going to replace B. We're going to make C using B, and we're going to replace one of the values of B with something that we want. So let's say, let's change D equal to 6 or something like that. And then we'll go ahead and print, no, not replace, Reaper. Oh, you. There we go. Okay. Typing is hard, especially when people are watching. Okay. So now we have our instance C where it is equal to B except for D has been replaced with the number 6. So that's handy that's especially handy if you've got a particularly large data class with lots and lots and lots of members and you want to basically copy it all except for a couple of variables, which is, like, if you work with a lot of datetime objects, that's actually a common thing to do. And so this becomes a handy way of making near copies of existing data class instances. We've already talked about post init processing. Let's see, init only variables. So there are a few more things that we could cover, like metadata and stuff like that. Is there an interest in that? Or should we, I guess we can talk about inheritance. Let's see, mutable default variables. Oh, right. Okay, we've already covered that. So one more thing that we can cover is inheritance. Let's see. And so if we're going to declare class B and it inherits from A, we're going to do something similar where we're going to say, okay, we want to override the type of D, and we're going to say that it's now also a string. And we're going to give it a value of default value of ABC. And then we're going to add an E, and that's also going to be a string. And we're going to say that's DEF. Okay, so now we have this new class called B, and we're going to create an instance of it. And let's do this and that. Get A and B. Okay. So now we've got B, which inherits from A. Well, we also need to declare our class B as a data class. And one thing that this does is it basically constructs a new, there's an ordering to how it figures out what the inherited class does. Now, here I have another question for you, Brandon. You may or may not know the answer to this, so sorry to put you on the spot again. If I don't qualify the parameters to data class on the inheriting class, does it revert back to the defaults? So if I don't specify order and frozen in my child class, what does it do?
Yeah,
do you
that
know?
one I don't know.
Let's try it out. So first of all, let's just see if this works. Okay, cannot inherit non and frozen data class from a frozen one. Okay, so good to know. What's this? Oh, not enough blank lines. Thank you, PyCharm. Okay, so that worked. So you do have to specify. You do have to make sure that the parameters of your child data class are what you intend. So this is now. Let's experiment a little bit, because now I'm curious. So let's see what happens if we remove the frozen attribute from the parent class. Okay, so we can't mix and match frozen and non-frozen data classes in inheritance. Good to know. So let's get rid of the order on our child and see what happens. Okay, so it accepted it and it was able to create the object, so that's good. So let's do, let's set up some comparisons real quick and see, and see what we can do here. So we've got A, B, and C. So let's do print, and let's go A is less than B. Okay, so this is complaining. LT is not supported between instances of A and B. Okay. And I assume that when we run, yep. Okay, so our types are different. So it's automatically detecting that we're trying to compare. So data classes, when for your comparison operators, you can only compare between two instances of the same type. So even though there's a parent-child relationship, the data class says you can't compare these because we're just going to assume that you do not have the same member variables in each class, in each type. So that's rejected. Okay. And even if I do order equals true, let's put this back, frozen equals true. Yeah, and it's still complaining down here. Yeah, so we can't do that comparison. Okay. The only thing that so now if we want to do let's see, let's compare C and B, which are of the same type. So this should work because I've got order defined. Oh, not supported between instances of int and string. Did I do? Oh, I overwrote this with the wrong type. So let's go 1, 2, 3 like that. There we go. All right, so that is true. All right. So now I'm curious what happens if we remove this guy. Okay, so because order has been defined in the parent data class, it gets inherited by the child. So now I'm curious. Order equals false. Let's see what this does. Huh. That's interesting that the that if it's defined anywhere, it's available to all of the children. So okay, good to know. I guess explicitly defining it probably wouldn't matter in this case because order defaults anyway. So okay, we learned something interesting. All right, that's all I've got for today. Oh, let's see. There is also the isData class, which is a lot like isInstance, but it just tells you whether or not the instance of a class you're looking at, either the class itself or an instance is a data class. Let's see. We've talked about replace. We've talked about isDict. We've talked about fields. We've talked about the default factories for field. Yeah, I think we've covered just about everything. I saw this first used in our code base recently, and I looked it up, and I thought this is very useful. I should share this. This will hopefully enable you to avoid writing a lot of very common boilerplate code going forward. Brandon, is there anything you can think to add?
Well, I'm not sure what I missed.
Yeah, I was. That's also, yeah, that's putting you on the spot. I'm sorry. I think I've covered everything, but I think the only thing I left out was like metadata. Let's see, and we've covered all of the important parameters to data class itself and to creating field objects. So yeah, I think we've covered anything. Are there any questions? One thing I really like about these data classes is how well they take advantage of the new annotation functionality in Python 3. It works together very elegantly with MyPy, and it's definitely can save you a lot of work generating boilerplate for these, for what is a pretty common programming case.
So this became available in which version?
Python 3.7. So it's only available in the most recent version of Python.
And that's newer than what the Python 3 port of Voltron aimed for, right?
Yeah, the Python 3 that Voltron is shooting for is 3.6.
Okay.
Of course, there's nothing stopping you from writing an agent that requires 3.7, and just because if Voltron works in 3.6, it'll work in 3.7. So I see no harm in that for your particular specific agent work.
Yeah, there's a backported version as well.
I was wondering that. How far backported is it? Do you know?
Well, I know it was working with Python 3.6, but I imagine it goes back to 3.4, but that's just guessing.
Okay. I mean, you look at it. It probably works in any version that supports annotation. So the question is when did annotation was added to Python 3? Was that 3.4, or do you remember?
The class annotation, or whatever the class.
The type annotations.
Type annotations is with the earliest Python 3, I think, like the earliest supported anyway, 3.3.
Oh, okay. I didn't realize it had been around that long.
Yeah.
Okay. Yeah. So in theory, it would work with any. You could get it working with any version of Python 3 that supported type annotation. So, yeah. Well, and that's. I don't see any for the internals of Voltron. I can't think of any places where we'd actually need something like it. But for classes, well, okay, I take that back. For classes and services that essentially need to take dictionary instances and throw them over the wire, maybe I ought to submit this as a feature suggestion that that the Voltron message bus support data classes, because it would be easy to do. Is this a data class? Yes. Okay. Well, turn it into a dictionary and ship it.
So I just checked. It's only backported to 3.6.
Okay. Well, I'm sure having it in the, just as a general rule, having it in the requirements for Voltron, the Python 3 version of Voltron, would be a simple request, and then it's just available. And then it'll just be available to everybody who wants to write for the updated platform. Thanks, David. That was a good question. Are there any other questions? Okay, if not, we will call it a meeting. Thanks everybody for showing up.
Thank you.